Today we're looking at section 2.4. We're looking at real and complex zeros. Example 1. Find the polynomial with a leading coefficient of 2 that has a degree of 3 and zeros that are located at -1, 3, and -5. Okay, so we know we have to have a 0 at x equals -1, x equals 3, and x equals -5. If the 0 is -1, what is the factor that produces that 0? X plus 1. What is the factor that gives us x equals 3? X minus 3. What is the factor that gives us x equals -5? X plus 5. Now, that gives me 3 factors. If I multiply those 3 factors together, what is the degree of that polynomial? X cubed. What degree did I need? I needed a degree of 3. What's the only thing I've left out? I need a leading coefficient of 2. So I'm going to put that leading coefficient in front. And then in front of that equals f of x. And that's my polynomial. Okay? That is my polynomial. On example 2, find part A. Any polynomial that has a degree of 3 with the zeros at -1, 3, and -5. How is that different than example 1? Okay, it's not telling me anything about a leading coefficient. Instead, it just says, give me any polynomial. So in that case, it wants it a little bit more generic. And so when it wants any polynomial, instead of putting an actual number in front of it all as the leading coefficient, we're going to put the variable a. A is going to be the placeholder of the leading coefficient. And then I have my factors, x plus 1 times x minus 3 times x plus 5. So that's how we need to write it for any polynomial that has that degree with those zeros. Most of the time for this particular thing, we'll use a, because if we FOIL all of this out, every general polynomial follows the form ax to the nth plus bx to the n minus 1 plus cx to the n minus 2 and so on. So a is always that leading coefficient. Okay, good question though. Now on part B, it's a little bit more specific. Find the polynomial from part A, so with a degree of 3 and zeros at -1, 3, and -5, but this time it has to go through a specific point. It has to go through the point 0, -45. Okay. So in this case, when it has to go through a specific point, this is how you're going to solve it. The point you're given, 0, -45. Well, that's your point x comma y. But that we can also write as x comma f of x, because f of x and y are interchangeable. They mean the same thing. So in place of f of x, I'm going to plug in -45 equals a, my leading coefficient, times, now in each of my factors, instead of putting down x, I'm plugging in the x value of 0 for that particular point. So 0 plus 1 times 0 minus 3 times 0 plus 5. So what I've done is I've plugged in the x value for the point, and I've plugged in the f of x value for that point. What's the only thing to solve for? A. We're solving for A and finding the specific leading coefficient that will work for this particular polynomial. So -45 equals A times 1 times -3 times 5 So 1 times negative 3 times 5 is negative 15. So negative 45 equals negative 15a. Divide both sides by negative 15. And so a equals 3. So the last step is to write the actual polynomial with that particular leading coefficient. So f of x equals 3 times x plus 1 times x minus 3 times x plus 5. That is the polynomial that has those zeros and goes through that point. Okay. Questions on that? Let's look at example 3. Find the equation of the cubic function with the given table of values. So my table of values, I have the point negative 2, 0, 1, 0, 2, negative 4, and 4, 0. Is this much different than the previous examples?
Yeah.
Not really. Am I given the zeros of this particular function? What are the zeros? Negative 2, 1, and 4. So what's the factor that gives me negative 2? X plus 2. What's the factor that gives me 1? So x minus 1, good. And what's the factor that gives me 4? X minus 4. Well, I have some leading coefficient out front that's a, and that has to equal f of x. Now in that table of values, what else was I given? The point 2, negative 4. So it has to go through the point 2, negative 4. So where am I going to plug in negative 4? For f of x, yep, equals a times, and where does the 2 go? In for the x's. So 2 plus 2 times 2 minus 1 times 2 minus 4. So negative 4 equals a times 4 times 1 times negative 2. What is 4 times 1 times negative 2? Negative 8, so that's negative 8a. Divide both sides by negative 8, and we have a equals 1/2, because it's negative 4 divided by negative 8. So that is 1/2. Now we can write the polynomial. F of x equals 1/2 times the factors x plus 2 times x minus 1 times x minus 4. That's what we have to do for that part. For that part. Any questions?
So they give you the point you.
Yep. Gives you the zeros. So from the zeros, you write your factors. Then the extra point, do you use that to plug in for x and f of x and solve for a, the leading coefficient? Okay. All right. Now, doing something a little bit different. Example 4. We need to take the polynomial x cubed minus 3x minus 2, and we have to divide it by x plus 3. So, did you do in Algebra 2, did you do some long division?
Yeah.
How'd you like long division? Not so much fun? What other kind of division did you do? Synthetic division. Do we like that better? No? Yes. Everything we do in here will be synthetic division. We're not doing any long division stuff. Ever. Ever. It's all synthetic division. So, do you remember how to do synthetic division? Kinda. A little refresher will help get you there. Okay. First thing we do is we take the polynomial, and the polynomial has to be the highest power down to the lowest power, so they have to be in order. If a power is missing, we have to put a 0 in its place. We need a placeholder of a 0. And what we're writing down first are all of the coefficients. So we start, the highest power is x cubed, so that has a coefficient of 1. Going down from x cubed would be x squared. Do we have that term? No, so I need a placeholder of 0 for the x squared term. Do we have an x to the first term? Yes, and what is that coefficient? So -3, you have to take the negative sign with it. And then an x to the 0 would be the constant, which is -2. Okay. In front of that line, I'm going to draw a half box. And in the half box, I look at the x plus 3, what I'm dividing into it. If I say, well, I'm checking to see if this is a 0 of the function, then if the factor is x plus 3, what's the 0? -3. So -3 is what goes in the box. What we're doing here is we're checking to see, is -3 a 0? Meaning that x plus 3 is a factor. Let's check it. We're going to skip a line, and then I'm going to draw a line. And then between the -3 and the -2, below that horizontal line, I'm going to draw a small vertical line. Okay, so we start with the very first number, which is the 1. Okay, the 1. I bring it straight down below my horizontal line. Any number that is brought down is multiplied times the number in the box. So 1 times -3 is -3. That goes in the very next column, so that'll go underneath the 0. Now we add 0 plus -3, and that is -3. I multiply that number, -3, times the number in the box, -3, and that gives me 9. 9 goes in the very next column, and it'll go then underneath that -3. Now I add these. -3 plus 9, 6. Multiply 6 times the number in the box, -3. That gives us -18. -18 plus -2, -20. To prove that x plus 3 is a factor of the polynomial, we would have to end up with a remainder of 0. But because we actually have a remainder, so this number that you're left with is the remainder, that means x plus 3 is not a factor of this polynomial because we ended up with a remainder. You have to have a remainder of 0 for that to be a factor. Now, to write your answer, okay, our result. If I started with x cubed and I divided it by x to the first, what is x cubed divided by x to the first? X squared. Okay, so this first one in our result is 1x squared, and then we go in descending order. -3x plus 6, and then for the remainder, we would write that as, since it's a negative, -20 over x plus 3. And that's how we can write our answer. The result after that dividing. So if x plus 3 is not a factor, that means -3 is not a 0 of the function. Okay, let's try the other one. The other one, we're dividing that same polynomial by x minus 2. So I need to write out the coefficients, 1, 0, -3, -2. This time, what number goes in the box? What am I checking? +2. Bring down the 1. 1 times 2 is 2. It goes underneath the 0. 0 plus 2 is 2. Multiply that 2 times the number in the box. So 2 times 2 is 4, goes in the next column. -3 plus 4 is 1. 1 times 2. -2 plus 2 is 0. So we've just discovered that x minus 2 is a factor of this polynomial. How am I going to write my result? I have a 1, 2, 1. So how will I write that out? Perfect. And that means that x minus 2 is a factor, and x equals 2 is a 0. Lauren. Right here? This 0 comes from the polynomial. The polynomial started with x cubed. I have to have a position for every x power starting with x cubed and going down. So do you see an x squared term in that polynomial? No, there's not one. So I need 0x squared as a placeholder, minus 3x minus 2.
Wait, where'd you get the 2 at the very end? Or the second one?
Right here, this 2, okay? I added the negative 3 plus the 4, which gives me the 1. Then I always multiply the 1 times the number in the box. Whatever I bring down, that number is multiplied times the number in the box, and that number goes in the next column. So 1 times 2 gives me 2, add it, and we have 0. Okay. All right, are you remembering synthetic division? Did it come back to you? Good. Any questions before we move to the next example? All right, example 5. Use the graph to guess possible linear factors of f of x. Then completely factor f of x with the aid of synthetic division. All of the graphs that are given here have a window setting where the x window is -7 to 7 and the y window is -60 to +60. Okay. This first function that is graphed is f of x equals 3x cubed minus 17x squared minus 16x plus 60. So looking at the graph, can we see what one of the zeros is? Is it falling directly on an integer?
Yeah.
Okay, which integer? -2. So from the graph, I see -2. X equals -2. What else do I see? X equals, what number is that out there? 6. 6. And what else? Oh gosh, okay, so that's kind of in between x equals 1 and 2. But how many actual zeros did we see on this graph? 3. It's crossing it 3 times. There, there, and there. So from the graph, I see 3 roots. Roots is another word for solutions. It's another word for the zeros. I see 3 roots. Well, what was the degree of this polynomial? The degree was 3. So based off of the last lesson, at most, how many zeros could it have? It should have at most 3 real distinct zeros. And it does. It crosses it 3 times. Okay? So we're going to take one of the 2 zeros where it's crossing exactly, and we're going to use that in the synthetic division. So my synthetic division, look at the polynomial. It starts with x cubed. Is every power of x accounted for going in descending order? Yes. So what's my first coefficient? And the next one is? -17, and then 60. Which one would you like to test first? 6. What if somebody had said -2? Does it matter? No, it doesn't matter which one you test first. So you're saying 6, so I'm going to put 6 in the box. Okay, so help me out. What do I do first in synthetic division?
Drop the first.
Drop the 3 down. Now what? Multiply it times 6, that gives me 18. 18 plus negative 17 is 1, so I bring that down. Then 1, what? Times 6 gives us 6. Add to negative 16, and that is negative 10. Then what? Negative 10 times 6 is negative 60, plus 60 is 0. 0. So that verified it is a 0 of the function. Now we need to use the result with the next 0 that I found. The next 0 was x equals negative 2. So I use the 3, 1, and the negative 10, and in front of that, I'm going to put the negative 2, and I'm continuing to use the synthetic division to break this polynomial all the way down. Question?
If you do it negative 2 first,
Uh-huh.
you would have got different numbers.
Yes. But then I would be using the 6 out front, okay? Even though I have different numbers, the result of this final one will be the same, okay? All right, so I'm going to draw my line. And we're not going to do anything with that 0 on the end, because that was the remainder, so we're done with that. Drop down the 3. 3 times negative 2. 1 plus negative 6. Negative 5 times negative 2. Positive 10 plus negative 10. 0. Okay, so I'm looking at all the factors because my goal here is to completely factor f of x. So when we originally looked at f of x equals 3x cubed minus 17x squared minus 16x plus 60, can you just look at that and automatically factor it? Nope, it'd be a little challenging. But with synthetic division, we've broken it down to all the factors. So f of x equals, look at this bottom one. That is your remaining factor. Think about what we started with. We started with 3x cubed. We did division once, so it broke it down to 3 what? X squared. I did division a second time, so now this is 3x to what power? The first. So that is 3x minus 5. That is a linear factor. 3x minus 5. Now the 0 was negative 2, so what is the factor that gave us negative 2? X plus 2. And the other 0 was 6. What is its factor? Careful. X minus 6. That is the polynomial function completely factored out. Daniel. Okay, because if I just do the negative 2 back with the original, then all I've done is I've just done it a different way of breaking the cubic down to a quadratic. My whole goal is to be able to get it down to a linear factor, so I want to be able to break it down as much as possible. So when you see 2 zeros on the graph, once you do it the first time, you're going to use the result from that synthetic division to continue to break it down further. So you use the second 0 with the result, and you keep breaking it down. So we start x cubed, now we break it down to x squared, divide again, and break x squared down to x to the first. Okay? Does that make sense?
Yeah.
Daniel? Make sense? Okay, good. Good. Other questions? Okay. Flip it over. The next one is x to the 4th plus 2x cubed plus 10x squared plus 18x plus 9. Look at the graph. What can we tell from the graph of this particular function? What do we see? How many roots?
One.
I see one root. Is there anything special about that one root?
Yeah.
What's special about it?
It's
It's touching, it's crossing over,
right.
it's tangent, so it means it has a multiplicity of 2. Okay? This one has a multiplicity of 2. One root with a multiplicity of 2. Now, even though a multiplicity of 4 would have the same tendency, we're not going to give you anything that has a multiplicity of 4 or 5 or so on. Okay? The most we'll give you is a multiplicity of 2 or a multiplicity of 3. Okay? On something like this. So that one root with a multiplicity of 2, where is that root at? What is the 0? X equals -1. Another term for that, we call it a double root. A double root. Okay. So let's go do our synthetic division. It's an x to the 4th polynomial. Is every power of x in descending order accounted for? Yes. So let's write out our coefficients. 1, 2, 10, 18, and 9. In the box in front, I am testing the root, -1. Okay, let's do our synthetic division. Bring down the 1. 1 times the number in the box of -1 is -1. 2 plus -1, 1. 1 times -1. 10 plus -1 is 9. 9 times -1, -9. 18 minus 9. 9 times -1, -9 plus 9 is 0. We started with x to the 4th. Our result is now where? X to the 3rd. Okay. Now, what's special about this one was -1 is a double root. It had a multiplicity of 2. So because it has a multiplicity of 2, that means we use -1 again. So we use -1 twice in our synthetic division. Question? Do you see on the graph where it touches, it does not cross that over, it bounces, it's tangent to the x-axis? That means it's a double root and it has a multiplicity of 2. Okay, we can tell that just by looking at the graph, that it's a multiplicity of 2. So because I can use it twice, in front of my resulting line, I'm going to draw a box and I'm going to use -1 again. Maybe, if my pen decides not to go totally bonkers. Let's try that again. Okay. So now breaking it down. Bring down the 1. 1 times -1. -1 plus 1 is 0 times -1 plus 9. 9 times -1 plus 9 is 0. Dividing it that second time, now this result starts at x to what power? X squared plus 0x plus 9. Did we have any other zeros that were given to us in this graph? No. If you think of x squared plus 9, can that be factored any further? No. So since I'm looking for all of the factors, that is one of my factors of this polynomial. X squared plus 9 times, if -1 was a root, what's the factor that gave me that? X plus 1 but it's squared because it had the multiplicity of 2 based off of the graph seeing it bounce. And it's tangent to the x-axis. So that is the function completely factored. That is the function completely factored. Okay? Now, what was the degree of that polynomial? So the degree was 4, which means how many solutions should I have? I should have 4 solutions. Well, that -1 was a multiplicity of 2, so how many solutions is that technically? 2. So I had 2 real solutions. Okay? And then what's going to be my other 2 solutions? X squared plus 9. If I actually solve that for x, it's going to give me what kind of number? Imaginary. So I'm actually going to have 2 imaginary solutions if I actually solve that one any further. Okay? Questions? Yes? Okay. I started with x to the 4th. I did division once, and so this result on this line would have been x cubed. X to the 4th divided by x is now x cubed. I did division again, so now that x cubed is now x squared. Okay, because we started at x to the 4th, divided once, now we're at x cubed, divide again, now I'm at x squared. You're subtracting every time. Yes. Let's try the next one. X cubed minus 8. Where's the graph? It's in your mind. Or I'll put it up here on my board. What? Not including the graph? No, we actually want you to be able to graph it on the calculator your own sometimes. But to save a little time, I'm not going to have you get up and grab the calculators. So I'll graph it up here. So x cubed minus 8. And standard window. Let's see what we get. Okay, so here's the graph. From the graph, what can we see? We see a 0. How many zeros do we see? 1. Okay, so from the graph, I see 1 real root. Well, what was the degree of this polynomial? The degree was 3. So how many total solutions should I have? I should have 3 total solutions. So if I only have 1 real root, what does that mean for the other 2 solutions? They're going to be imaginary. So I'm going to have 2 imaginary solutions. Yeah, if we were taking it all the way down, breaking it all the way down, solving for x, I would end up with 2 imaginary solutions. Now, just as a side note, imaginary solutions always come in pairs. So it would either have to be 2 imaginary, or 4 imaginary, or 6 imaginary. You'll never just have 1 imaginary solution. They always come in pairs. Okay, well, what is that root that we just saw? Where is it occurring at? At positive 2. Okay, so we see that root is at x equals 2. So now I have x cubed minus 8. Do I have all powers of x accounted for? Nope, what am I missing? So I'm going to hold a place. So plus 0x squared. What else? Plus 0x, and then minus 8. So I have 2 placeholders, one for the x squared term and one for the x to the first term. Write down the coefficients. 1, 0, 0, -8. And in the box, I'm going to use 2. Okay, let's do the synthetic division. Bring down the 1. 1 times 2 is 2. 2 plus 0, 2. 2 times 2 is 4 plus 0. 4 times 2, 8. 8 plus -8, 0. Did I have any other 0 or root that I could use with synthetic division? No. I started with x cubed, divided once, so now my result starts with x to what power? X squared plus what? 2x and plus 4. So now we write this in factored form. F of x equals x squared plus 2x plus 4. And what's my other factor? X minus 2. Because that comes from the actual 0, the actual root that we saw from the graph.
Would it be necessary to refactor that to x squared plus 2x plus 4?
It can't be factored. If it could have been factored, that would have shown up on the graph as other zeros. But my other two solutions here are going to be imaginary, so that also lets me know it can't be factored any further. Okay. Other questions? All right. I'm actually going to stop there for today's part of the notes. We're going to finish the notes tomorrow. What we're going to talk about right now is a project.
Monday?
What? Oh, yeah, Monday. We'll finish the notes on Monday, yes.
What is-